name is Michaela Glennon. I am the Science Director for the Paul Smith College Adirondack Watershed Institute. I hope if you found this video, it means that you had a chance to see the wool and water display in person, but if you didn't, I'm excited to give you a little bit of a background of what the display is and what its purpose is. The Adirondack Watershed Institute is a program of Paul Smith College, and we are a science organization, and central to our mission is the protection of clean water and healthy watersheds. We are in the process of embarking on a project to celebrate the upcoming 50-year anniversary of the Clean Water Act, and we hope to use a collaborative science and art approach to use yarn and fiber and knitting and crochet and other crafts to illustrate water quality and the importance of waterways in our lives, to illustrate long-term change in those waterways, and to celebrate the Clean Water Act that has helped to protect them. The display, called Wool and Water, was originally created to celebrate Water Week in 2021, and we hope to have the project run over the course of this winter and to display the resulting creations from this project during Water Week, the last week of August in 2022. So take a look at all the pieces that are a part of the display. I try to provide some background on how I created them, particularly for the fiber-oriented folks who might be watching this, who might like a bit of detail on how each of them were made. And my contact information is on the last slide. I would be thrilled to hear from any of you who would be interested in being a part of this project. Thanks. The first piece I'll talk about is one that is meant to illustrate the concept of lake stratification. In northern climates and places with lakes like the Adirondacks, those lakes are heated by the sun in the summertime, and the solar radiation from the sun heats up the upper layers of the lake, which eventually develops into three different temperature zones that are called the epilimnion, where a lot of mixing goes on. That's the warmest layer of the lake. The metalimnion and the hypolimnion, which is the coldest, deepest parts of the lake. The metalimnion is the layer between the epilimnion and the hypolimnion, and the thermocline is the area within the metalimnion in which the temperature changes most rapidly with depth. And you can feel these layers when you swim in our lakes in the summertime and you stick your feet down and reach into some of the colder layers of the water. In the wintertime, the lake has a bit of stratification still to it, but not nearly as pronounced as what there is in the summertime. Late in the fall, as the solar incoming radiation from the sun decreases, the layers of the lake begin to mix, and eventually the thermal resistance to mixing breaks down, and the lake turns over, as it is called. It's actually a mixing of the whole volume of water within the lake. During the winter, most of the temperature in the lake will be around zero by the ice layer, and it might range down to only about 4 degrees. So there's a bit of stratification, but not nearly the pronounced layers that exist during the summertime. So this is a hat and some fingerless mitts that are meant to illustrate that concept. The mitts both have beads on them that actually show the temperature profile. If you were to go onto the website for our Upper Saranac Lake monitoring platform during the summer and look at the temperature depth profile, you'd see a curve that looks like those beads, and so it shows you how that temperature changes with depth and how it changes most rapidly in that metalimnion layer at the thermocline. And during the wintertime, of course, there's ice on the surface of most of our lakes, and not much of a temperature gradient, and that's illustrated in the left-hand mitt. The hat similarly shows those layers of strong stratification in the summertime, and it's reversible. And if you flip it to the other side, it will show you just a wintertime profile without much stratification. So that was made with a free hat pattern, and likewise a free fingerless mitten pattern that I found right on Ravelry. The next piece illustrates the concept of bathymetry, which is the depth profile of a given lake. So bathymetry is sort of the underwater analog of topography and is often mapped in a very similar way with contour lines that illustrate different levels of depth. In this case, the depth is under the water rather than height above land like we would see in a topographic map. The Otsego River Association has this beautiful bathymetry map of Mirror Lake on their website, and so what I did to illustrate this concept was to crochet a whole bunch of tiny circles in varying colors of blues and greens, and then attach them to one another in a way that mimics those depth profiles for Mirror Lake. Next piece is the Champlain Ice Scarf, and what this is a record of the long-term dates of ice closing or not closing on Lake Champlain, which are available right on the National Weather Service webpage there. And so you can see this record goes back, I think, to about 1818, and each year provides the date that the lake was recorded to have frozen. So in the scarf that I created to represent this, each of the white rows are years when the lake froze, and each of the bluish rows are years when the lake did not freeze. And if you were to take that scarf and sort of look from the whole length of it, you can see that the blue stripes become much more frequent at one end of it, and that is the more recent times when more and more often the lake is not closing completely. If you look close in on the scarf, you can also see that there are tiny white beads in one of 3 columns in that Tunisian crochet stitch pattern there. I put those there to actually illustrate the month that the lake froze. So if it's the year that the lake did freeze, if it's in the leftmost column, it froze in January. If it's in the middle column, it froze in February. And if it's in the right-hand column, it froze in March. And that too has sort of shifted over time to later dates of ice closing. The next piece is the HAB Bag, and this is illustrating what are called harmful algal blooms. Algal blooms are a natural phenomenon of growth of microscopic algae, but at certain times they can become out of control and produce toxins that are dangerous and in some cases lethal to a variety of different organisms. And so you may have heard about harmful algal blooms or HABs, and the state does track them with maps that are keeping track on sort of a real-time basis of reported HABs. This is a phenomenon that is increasing in lakes everywhere, including in the Adirondacks, and because there are health consequences for humans and for our pets and other organisms, we do need to pay attention to this important and troubling phenomenon. So what I did here was to try to represent the increasing frequency of harmful algal blooms that have been reported in Adirondack lakes since 2012 in a felted bag. I did this in a relatively simple way from a fiber standpoint. I just used a flat piece that I crocheted, and the rows within each row I used that puff stitch there, which is sort of the green blobs on the bag, to represent each of the HABs that occurred in each of those years. So if you go from the top of the bag, there is actually 5 of them in 2012, all the way down to the bottom of the bag. The bottom row of the bag has 15 of those puff stitches to represent the increasing number of HABs that are now occurring in more recent years. I did this with crochet. You could certainly do it in knitting or other methods as well. I invented the pattern myself. I just stitched the flat piece and then sewed it together and created a bottom piece for it, and then created a strap for it, put it all together, and then felted it by hand. Felting is the process where we can take a natural animal fiber and, using very, very hot water together with a little bit of soap and a lot of agitation, can turn it into a really durable felt material. And so that's another illustration of the importance of water and what it can do for us in the fiber arts. I just made this pattern up, but you could certainly look on Ravelry again for all kinds of free felted bag patterns that are available there. The next piece is an illustration of dissolved oxygen. It is actually the dissolved oxygen profile for Upper Saranac Lake in 2017 between June and November. So if you look at figure 5 there on the slide, the bottom right-hand corner is the picture of what dissolved oxygen levels look like in the lake starting in June and going through November, when we have to take the profiler out of the lake. During the summer months, oxygen gets used up in the lake, especially at the lower levels, at the sort of water sediment basin boundary, by biological processes. And this is, of course, a natural phenomenon, but at times this can build up a hypoxic layer, which is generally common occurrence, but it can become a problem when that hypoxic region of the lake becomes very large. And so this is an illustration of a lake like Upper Saranac Lake, where we do see this phenomenon in deep lakes like that lake, and especially in that part of Upper Saranac Lake in the Big Hole where the profiler resides during the summer months. So this was done, again, in a fairly improvised way. I used a free online resource that's called Stitch Fiddle, which enables you to take pretty much any image and turn it into kind of a pseudo knitting pattern. So I took that figure there and put it in there and came up with a pattern of those colors. You can manipulate the number of colors you want in your pattern. You can manipulate sort of the resolution of it, or the number of stitches that you would need to use to create it. And so I did that with just knitting with the resulting pattern. It's a little bit fiddly knitting because there were a bunch of colors involved, but you could simplify it if you wanted to. And then again, I felted it by hand. I generally felt everything by hand because I enjoy the control over the process. But it does mean that you spend a lot of time with really hot water and hopefully some really thick gloves in your kitchen. This next piece is one that I called the Raquette Wrap, and it is representing two different patterns of change in Raquette Lake and in its watershed. Raquette Lake is part of our long-term monitoring program, HAB, the Adirondack Lake Assessment Program. And Raquette Lake has been monitored by volunteers for HAB since about 1993. And so the water quality trends in Raquette Lake have been well tracked over the years. I have also monitored boreal bird populations in all of the lovely fen and bog and peatland inlets and outlets on Raquette Lake. The Marion River fen, the South Inlet fen, each of those lovely little spots has been tracked for the specialized boreal birds that live in those places and how they have changed over time. So what is illustrated in the Raquette Wrap is two different patterns of change. One is the declining lake transparency in Raquette Lake, which is a pattern that we are seeing actually in a number of our HAB lakes, of declining transparency of the lake, declining depth at which you can visualize a Secchi disk that's placed at increasing depths within the water column. So the lake is getting less clear and darker. The other thing that I'm trying to show in this piece is the declining occurrence of these specialized northern bird populations and the degree to which they are becoming more difficult to find in some of our peatlands in Raquette Lake and other areas of the Adirondacks. The declining pattern of transparency may or may not be as a result of climate change. It's possible that climate change is driving that trend. It is, however, also possible that declining lake transparency is actually a sign of recovery from acidification, which is a very positive trend. And so it's a bit unclear what exactly the transparency trend means in this and other lakes, but it is a phenomenon that we're seeing in a number of different lakes. The decline of boreal birds, unfortunately, is probably related to climate change. I did this with another pretty much improvised pattern, but I followed the basic idea of a log cabin knit shawl pattern, and I've linked that on the bottom there. I just did it in Tunisian crochet instead of knitting. I tend to use Tunisian crochet when I'm trying to create something fast because it's really fast. And I took each of the data sets that are represented here in these graphics and just used colors to represent, in the case of the blue, darker colors representing declining levels of lake transparency over time, and the greens are representing the birds, in this case trending toward lighter colors, which would represent fewer boreal birds in these waters. Among the stressors that impact our waterways in the Adirondacks is road salt. And over time we have seen tremendous use of road salt in the Adirondacks over many decades, resulting in increasing levels of sodium and chloride in our lakes. This again is a phenomenon that we're seeing as a result of looking at long-term data from our lake assessment program and monitoring water quality. This can have impacts on a number of different organisms and processes, and those include amphibians. And in fact, recent work by the Darren Freshwater Institute has illustrated that road salt and elevated chloride levels in waters can alter the sex ratio of amphibians, particularly wood frog tadpoles that were exposed to chloride. So it does have important biological implications. And I wanted to illustrate that with this frog. I used a free frog pattern that I found online, and the beads on his back represent the increasing levels of chloride in Rich Lake between 2003 and about 2018 or 2019 that you see on the graphic from our HAB report in 2018. The next piece is called the wind throw, and this one is meant to illustrate almost a day-to-day way that you could engage with data and create an ongoing piece that would become as big as you would like it to. And so what I've done here is to visit the Upper Saranac Lake platform that we maintain. The URL is at the bottom there. And if you go there at any time, day or night, you can get the current conditions on the lake, among other things, but you can get a whole bunch of weather data right there instantaneously. And I just started keeping track of that, not in any systematic way, but at random times. I would go to the weather, go to the current conditions page of the platform and note each of those different weather parameters. And then I just chose a couple of them to illustrate in this wind throw. So what I did was to develop a range of blues that represent the air temperature, and that's the middle of the circle here, and a range of greens that represent the wind speed at that same time. And then if you look close, you can see that I also put a bead in there on the edge of the second circle to represent the direction that the wind was blowing from at any given time. So this, again, is something that you could do. You could make as many squares as you wanted. You could make a scarf all the way up to an afghan. If you chose to, you don't need to use the parameters that I used. You could choose any of these different weather parameters, but I thought it was kind of a neat modular approach that you could add to for as long as you wanted to, and you could track it for as long as you wanted to with data that are readily available and would tell you what's happening on Upper Saranac Lake in a way to illustrate that phenomenon. I just improvised these, but there's an abundance of sort of crochet or knit circle within a square patterns around on the internet that you could use to do a similar kind of approach. Last, there are two other pieces that I included in the display, even though they are a bit divorced from our theme of water. They are nevertheless really interesting illustrations of data knitting and sort of science and art, and temperature, in fact, is a pattern that is often represented in knitting already. There are many examples of temperature blankets, for example, that people have created, in part because temperature data are readily available. In many instances, the longest records that we have come from climate. We can find records that can be represented easily over long time frames. It's harder to find those kind of data from other areas of science, and in part because temperature just lends itself so well to colors and being represented in colors. So the right-hand side here is a picture of tapestries, and these are representative of the Tapestry Project, which is an established project that anyone can participate in which you knit up or crochet or weave what's called a tapestry, which is a year-long representation of the maximum daily temperature at a given location. Oftentimes people will knit two of them so they can look at the change over time. And again, the link to the Tapestry Project is there on this slide. There have been tapestry collections developed for a lot of places. There's a national park collection. There are collections that associate with a particular city. I created a group for folks that were interested in creating a tapestry for somewhere in the Adirondacks. So if you're interested in that, I would love to have you as a part of my Adirondack tapestry collection. We're slowly chipping away at that and trying to develop a collection for here. Very often these things are used in things like climate marches and ways to engage people in the idea of visually illustrating climate change and what it looks like. The left image is another similar example, and that's a dress that I made to again represent changes in temperature. In this case, what's represented in the dress is actually deviation from long-term normals, and so that's a climate record that goes back to about 1880, in which each year is a row on the dress, and the colors correspond to the extent to which the temperature in that year deviated from our long-term climate normals. And so at the bottom is more recent years, and of course the extent to which we are deviating from sort of long-term climate normals has gotten more pronounced over the years. And again, I included this in the collection because they're good examples of knitted data, although they're a little bit separate from the water theme of the larger project. So I hope that you have enjoyed learning about these pieces, and I hope you'll consider joining us for the Wool and Water project that we hope to embark on over the course of the next year. We received a grant from the Champlain Valley National Heritage Partnership, which is the Lake Champlain Basin Program in partnership with the National Park Service, and we aim to spend the winter time, the time between now and Water Week of next year, which is the last week of August in 2022, creating pieces like this that can help to illustrate long-term trends in the Champlain Basin and beyond, and can help us to celebrate next year's upcoming 50th anniversary of the Clean Water Act. My contact information is here. I'm interested in having anyone participate who would like to. We hope to travel to a number of schools in the region and see if there are students who would like to be involved, but anyone who would like to, I would love to have you participate in our project. So shoot me an email. You can find me on Ravelry as well, and watch our social media over the coming months, and we'll be putting out more information about the project and how to get involved. Thanks so much for watching.